Welcome! This is a short tutorial to help you get started with creating graphical apps in Python. We will be creating a simple old school screensaver. So if I click run, you will see that we have some sort of nice background image and we have some foreground images going around on the screen and bumping off the walls. And every time we run it, they will be at slightly different angles and it will never be exactly the same. Now, just a little tiny bit of background on this. Screensavers basically used to be a really big thing. There are some iconic old screensavers like the DVD one when you didn't have a DVD in the DVD player, or this particular old Pipes screensaver, which was famous on a lot of old Windows computers. The basic idea was to have something moving on the screen permanently to avoid burn-in, but over time they became more decorative and more interesting. But these days, in the interest of power saving, usually we just have the screen gets automatically turned off after a certain amount of time. But that doesn't mean it's not interesting to make one. For this project, we will be using a free online tool called CodeSculptor 3. This is not something you would create a professional app with, but it's a fantastic way of learning. It's a simple web-based Python coding environment that's ideal for creating basic graphical Python programs with a GUI interface. And what we mean by a GUI, a graphical user interface, is when we hit run, is we have a window and we have buttons we can click and we have a canvas that the program can draw to. So let's have a quick look at CodeSculptor 3 and how it works. So first of all, just so you know, if you hit save, it will actually change the URL at the top of the screen. You can't see it here, but you'll see on your computer. And what you need to do is once you've hit save the first time is you need to bookmark that page. So if you click on the star in the address bar, that will create a bookmark for you, and then you can go back to your project anytime you like. Every time you make a change and then you hit save again, it will actually keep the same address except the last number will change from a 0 to a 1 to a 2 to a 3, and so it will actually keep all of your different versions in there of your program, so you can go back to previous versions if you like. If there's something that you don't know how to do in CodeSculptor 3, it is very well documented. If you click the docs here, it will open up, and if you go to graphics modules and canvas, those are most of the things you'll probably want: how to draw text, how to draw images, etc., etc. But definitely this graphics module section is the one that you want. Now, a graphical user interface is not something that's built into Python directly. So you'll see here in this little example program that is up on the screen when you go to CodeSculptor 3, you actually have to import Simple GUI. And if you go on to make other GUI programs later, you'll probably use a different library that will work a little bit differently. But this is a really nice, easy way to get started. Let's have a look at this example program here. If I click run, it says welcome, and when I click on the click me button, it changes to good job. So I'm going to go through this step by step just to have a quick idea of roughly how GUI programs are set up, because it's a little bit different to a command line Python program. So first, you can see here we've imported Simple GUI, the library, then we've just created a variable and called it welcome. Now keep in mind that does not draw it onto the screen or anything like that. It's just stored in the machine under the name message. Now, what we have here are two functions. One of them is called click, and it doesn't have to be called click, but this function is basically what runs when you press this button here. And then the draw function is what runs 60 times a second when your monitor is ready to redraw or to refresh. Now, those don't automatically happen on clicks and draw. That's what this next section is, which is setting up the frame. So this is the frame. So frame, we've just called it frame. We could have called it my frame or window or something like that. It's up to you, but we've called it frame here equals simplegui.createFrame, so that'll create the new frame for us. The first parameter here is what it's called in the top left-hand section there. Then we have the width and the height in pixels. Now the next thing that's done in this program is they've added a button onto the frame. This is what it says on the button, as you can see here. And this is the function that will run when the button is pressed. So I said this didn't have to be called click, you could call it button press or something like that, as long as you put the same name in here. Then we have to tell Simple GUI which function we want to run 60 times a second, and we've told it that that's the draw function here. And then the final thing that's happened is we start the frame. So this behaves a little bit differently from a text-based command line Python program. Basically, all of this setup happens pretty much instantaneously, and then all the code that gets run after that point is in these functions that we call them callbacks. So the program actually calls back into our code when either a click happens or the screen is ready to draw. So you can imagine every time there's a click, this function will run. Every time the screen's ready to redraw, this function will run. And another word for this is event-driven programming. So it's basically the idea that these functions run when certain events happen within the program, whether it be a button click or user input or the mouse moving or something like that. It's a little bit of a different way of thinking about things, but you will get used to it after a period of time. So let's get started on our project. I think we can use most of this boilerplate code, but there are some things that we won't need. So for example, we won't need the variable welcome or message, and we won't need this click handler. We will need the draw function, but we won't need to draw any text on the screen. And for the moment, I'm just going to write pass in there because Python doesn't like having empty functions. We'll definitely want to create the frame, but instead of home, I'm going to call it Screensaver. And for a size, I'm going to make mine a little bit bigger. You play around with whatever size suits you, but I'm going to do 800 by 500. We won't need to add this button. And that's all we should need for the start. So if we hit run, it says Screensaver here, and we have a nice big canvas. So we are all set up and ready to go. Alright, so the first step I would like to do is get a nice background image drawn onto the screen. And so mine is going to be some animals moving around in a garden. So as a result, I would like to go and get a garden image. So you can see here, I've just done a Google search for natural garden, and having a look through here, I think something like this makes the most sense because it has a lot of grass in the foreground here, and I would like my animals to be sort of moving around in this area on the grass. So what I'm going to do is I'm going to right click here and go down to copy image address. Now you don't want to get this wrong. No, it's not copy image, you want to copy the image address. So I'll click that. And back in Code Sculptor, I'm just going to paste it here. Now we're going to have to put in a little bit of code to load this image, but I'm just leaving it there for a second as I head into the documentation. And in the documentation, we can go to graphics modules, which is usually we're looking up how to do GUI stuff, right? The basic Python, we shouldn't probably have to look up so much. So we're going to graphics modules, go into canvas because we're drawing on the canvas, and you can see one of the functions is canvas.drawImage. And you'll notice here that it has a few examples here, and you can see that we actually have to load the image first. And so I'm going to go to the load image, if I can find it. Well, I might just copy and paste this bit here, the canvas.load image. So I'm going to copy this, Control C, and go back here and Control V. Now I am going to change this to background. I'm just going to call it background because basically this is a variable that we are going to store a link to the loaded image inside, and then the code will be simple GUI.load image. Now remember what that means is go and get the simple GUI library, and it has a function called load image within it. Now I'm going to get rid of all of this stuff inside here, and then I'm going to put talking marks because it accepts a string of a web address. So I'm going to Control X and Control V. I'll just check the bracket is on the end there, good. And now hopefully we should have the image loaded into there. One way that we could check is in here we could just say print background.width, and then when we run the program, oops, why is that not correct? I think it's actually get width. Let's try that. Okay, and it says that the width is 1920. That looks correct. So I think that load has actually worked. Okay. So now that we've loaded the image, the next step is to draw it onto the screen. So again, let's hop into the documentation here. And I'll go back into graphics modules, canvas, and draw image. And we are going to copy and paste this code. Actually, we don't know what all the numbers mean necessarily, so let's go in and actually copy the example one up here. We don't need rotation for this one, it's just a background, so I'll copy the top one, Control C, and I will go back into Code Sculptor, and we want to draw the image in the draw function. Now the draw function will run 60 times a second, and it will wipe the screen and then draw whatever we put in this function. So the first thing will be the background image. We want to draw the background first, then we'll draw the animals on top of that, otherwise we won't see them. So let's draw the background image here first. So it says canvas.drawImage. Now the first thing we need here is the loaded image, the variable pointing to the loaded image, which we have called background. Now the center of the source, this is where it gets a little bit tricky. We're just going to put a little list in here, and it's going to be two numbers. It's going to be the center of the source. Now the source, as you can see here on the Google search, comes up as 1920 by 1080. So if we take 1920 and divide by 2, that should be 960, I think. 960 and 540, hopefully. So I can put 960, which is halfway, and 540. So that should be the center of X, 960, and the center of Y, 540. Now the second one is the width and the height of the source, and we just looked that up. That's the whole number there. So it was 1920 and 1080, I believe. There we go. Now the center of the destination, I want this in the center of my whole screen, and seeing as though it's 800 wide and 500 high, the center of that should be half of those things again, and we'll put it in a little list here. So we could say 400 and 500. So the destination is the canvas that we're drawing it on, right? And the width and the height of the destination, that's our canvas. Well, that's how big we want to draw it on our canvas, but we want to cover the whole canvas. So that's going to be 800 and 500. Now, hopefully, fingers crossed, if I hit run, it will actually work. Oh, okay. So it's sort of correct, but it's down too low. So let's see if we can find the error in here. So we had 400. Oh, yes. And you can see, hopefully you realize that if you're watching at home, that I made that mistake. So halfway of 500 should be 250. So hopefully now There we go. That's actually covering up the whole canvas perfectly. Now, when it wants the coordinates here, it asks for them in a little list, just a list of two numbers. So for example, this was the original image, the source, the width and the height. So it was 1920 wide and 1080 high, and it wanted that in a list. Now I'm just going to quickly change these and explain. I'm going to change these from square brackets to these regular rounded brackets. And it will act in exactly the same way. Oops. But in Python, these are not called lists, these are called tuples. And basically the difference is that you can't modify them once you've created them, but that doesn't really matter because we're recreating this every frame that we need it. We're not going in later and saying, oh, change this or change that. So these ones you can't modify, but because of that, Python can run them faster. So it's a bit of a performance save. So let's do that. Make sure that it still works. Okay, good. And there we go. We have our background image. Now, I know that it can be a little bit confusing here with the center and the size, and you might say, why do I have to put all those numbers in? And that's because in the future, you might not want the image to draw the whole of the original image. You might want to draw just a part of the original image, or you might want to draw it on the canvas down in the left corner like this. So that gives us all of this flexibility, even though it's a little bit of a pain. And often it won't work at first. Just keep tweaking it, and hopefully it will after a little while. Okay, so now we're going to follow the same process to get an animal on our screen. I'm going to start maybe with a cat. So I'm going to go to Google, and I've just searched for cat here. Now, because this is going to be on the top of the background, I want to make sure that it doesn't have a background in this image. Otherwise, it's going to be a square block with a background on top of the other background, which won't look very good. So what we really want is one that just has the cat but no background. So if I go into Tools here and click on Color and Transparent, then hopefully if I click on one of these, you'll see it will come up after a while when it loads with this gray and white checkerboard pattern on the background, and that usually indicates that it is actually a transparent image on the background. So if I wanted to use this one, I would right click and say copy image address, and then go back to here and paste in the address again, and I can just copy and paste this here, but this one I will just call cat. You don't have to call yours cat, obviously. And we need quotation marks around the string, and we need to close the bracket. Now, just a quick note here. Obviously, if I was creating an actual app or program to release professionally or something like that, we would make sure that we have images that are copyright free. There are some fantastic websites that you can use, such as Pixabay and Unsplash and things like that. But for the purposes of this, it's just a little practice exercise. So it's fine to use whatever you would like. So we've hopefully loaded the cat image now. And then what we can do is we can Control C, copy this, and Control V. And this one, the cat image, we want to draw afterwards because it will then be drawn on top of the background. So I'll put the cat there. Now, it might be a little bit hard to remember what all of these things are, so I might even recommend going into the documentation here and Control C, Control V, after I do a hashtag to create a comment, and that way up here it's not actually going to run, it's just a comment for myself, and then I can remember what these things are. So image, we've done that. So center source, it was 800 by 800, I believe. So that would be sorry, that the center of the source would be 400 and 400. The width and the height of the source, which is the original image, is 800 by 800. And then the destination, I'm just going to draw it back in the middle of the screen, which is 400 and 250. And the width and the height, I'm not sure exactly, but maybe I'll just draw it 50 by 50 and see how that goes. Okay, there it is. That's very, very small in the middle. And you'll notice it actually took a little while to show up. So sometimes images take a little while to load. That's probably too small. Maybe I'll try 100 by 100. Okay, I think that's a lot better. So we have our cat in the middle of the screen. If you would like to have more animals on the screen, obviously you can follow the same process here. You might have dog equals simple GUI.loadImage and have a different one. And you can draw them like this, but I'm not going to go through how to do multiple different ones here because it's just the same process, and I'm sure you'll be fine with that. So now the interesting part is how do we move the cat around so that it moves on the screen in some different directions, and then when it hits the edge, how do we get it to bounce? So if we want the position on the screen that it is going to be drawn to vary, we need to put variables in here instead of hard coding it. Now it's this center destination part. So where do you want the center of the image to be on the destination? So right now you can see that the center of the cat image is at halfway here and halfway there. And because the screen is 800 by 500, that's 400 and 250. So I'm going to replace that with cat underscore x and cat underscore y. Now that won't work yet because we haven't created a variable called cat underscore x or y. So let's go and do that right now. I'll put it here. I'll say cat underscore x, and I just made that name up. You can choose something different if you wish. Equals, what did we say before? It was 400 and cat underscore y equals 250. And then to get access to these global variables in the function, we should type global cat x, cat y, like this. Hopefully this will work exactly the same way as it did before, but now we have the ability to move it around. So for example, if I went in here and did a tiny bit of code before we draw it, if I said cat x plus equals 1, then this function runs 60 times a second. So 60 times a second, we should move 60 pixels per second across the screen here, as you can see. Now, I don't want the cat to just move off in that direction. I would like the cat to have some sort of speed or velocity on the x-plane, going left or right, and going up and down, which would be y. So let's create a few more variables here. So I'm going to say cat vx, so velocity just means speed, x. So that's how fast is the cat moving left and right. And again, I just made up that name. You could choose a slightly different name if you wanted. So if I said 1, for example, and then if I said cat vy equals 1, and we'll add those onto here. So now we have, instead of saying cat x plus equals 1, we could say cat x add the velocity to that. So let's say the cat's x position is 400, then cat vx at the moment is 1, so at the end of this frame it would be 401, then the end of the next frame would be 402, etc. And then we'll say cat y plus equals cat velocity y. Now I just want you to think, if you're increasing the x value by 1 every time, that's going to push it off to the right, And if you're changing the y value by each time up, that's going to be pushing it down. So hopefully it'll be going at a diagonal off to the bottom right, hopefully. Yes, and you can see that that works. What if we get to the edge and we want to bounce? Okay, so maybe we should put some comments in at this point. So here I can just put a hashtag and say move the cat. And then here I can say bounce cat off walls. So how would we do that? Well, we know that the dimensions of the screen are 0 on the left, on the x-plane, and 800 on the right. So let's maybe just start with the left and the right. And maybe I'll set the velocity of the y to 0 just for testing purposes. So we can say if cat x is greater than 800, then what do we want to do? Well, we want to actually send it back in the opposite direction. So how we do that is we would say cat velocity x times equals -1. So for example, if the cat's velocity, x velocity, was 1 and it hits the edge of the screen, if you multiply that by -1, it then becomes -1 and it will go back in the opposite direction. And if it was 2, it will become -2. So if we look here, you'll see as we get to the edge of the screen, it should bounce back the other way. Okay, good. And the other thing is, if it's coming down on an angle here, because we're just changing the x velocity, it will then have a realistic bouncing angle like that because the y velocity doesn't get changed. So you'll see here that didn't work on the left-hand side, so we will need to do one on the left-hand side as well. Now we can probably use an elif here, else if, because if it's off on the right-hand side having a collision, it can't really be off on the left-hand side having a collision, right? Just before we do that, one thing we can do for safety here is we can also set cat x to 800. Now, the reason we might do that is just on the off chance that later on we're changing things around, and what can happen is it can get off the right-hand side of the screen and then sort of infinitely bounce back and forth. So just to save that possibility from happening, we'll do that. Okay, elif cat x is less than 0, then we'll set cat x to 0, and we'll say cat velocity x times equals -1. Okay, so now hopefully, actually I'm going to speed that up because let's say we'll do 5. So hopefully that'll bounce off both sides now. Good. All right, so let's copy and paste this, and on the y side it will be similar. So if cat y, but this time it won't be 800, it will be 500 because that is the maximum there. So change both of those numbers to 500, and all of these will be cat y, cat y. So if cat underscore y, the position, is greater than 500, that's off the bottom of the screen, then set it back to the bottom of the screen and flip its direction so it's heading back up again. And then here, if cat y is less than 0, then do these things, and hopefully that will work. So if I put in some numbers here, so I say, let's say it's 3, and let's say 1.3 or something like that, then hopefully that will bounce off both now, and it will go up. Okay, that's working quite well. And also, if you have a different side length like I do here for the horizontal and the vertical side, then hopefully you should get some quite different patterns going over time. It shouldn't just always do the same thing. Now, one thing that I might like to do here is make it a little bit more realistic in the sense that I probably don't want the cat flying around in the top of the garden here. So I might actually keep the cat, instead of bouncing off the very top of the screen here, I might say it'll bounce off if it's less than 200. So I can say here on the Y, which is up and down, I can say if it's less than 200, then set it to 200 and flip this. Okay, that's working pretty well. Why don't we add a little bit of randomness to this? So instead of having it always spawn at the same speed, we could say import random. Now, what that does is it goes and fetches a module, a Python module that can handle all sorts of random calculations. And we would use one of them here. We would say random dot, so that means go to the random module, and inside it there's a function called rand range. And I hope I get this right, but we could say, for example, maybe anywhere between 0.5 and 3. And so each time we run this, it should behave slightly differently. Oh, okay. I've got the wrong function here. Okay, so I had to pause the video here, and rand range actually gives you an integer result. So for example, it would have to be between 1 and 3, and that would return 1, 2, or 3. However, I would like some decimals there to mix it up a little bit more, and so as a result we need the random.uniform, and that way that should return a different number each time between 0.5 and 3. We can test this by typing print vx. So if we run the program, it's 0.915, etc. We run the program again, it's 2.43. And you can see every time it will be slightly different. So let's do the same thing here. So cat underscore vy equals random.uniform, a range between 0.5 and 3. Now, these numbers are just what I think would look good. You can basically choose whichever numbers you like, so don't stress that they are these ones. Just play around with what works for your program. So you can see the cat's flying off in that direction this time, and just to be clear, the cat will always start off moving in a bottom right direction, but it will be somewhere between this direction and this direction. So it could be down that angle, etc. It'll be slightly different so that every time the cat doesn't follow the same path as it did, or the same speed as it did in other times. Yeah. So we've done really well, I think, here, and it should be quite easy for you to add a second or a third item to your screensaver. You can follow the same procedures that we had here, create the variables for them, etc., etc. And I think you'd probably want to have at least one more for this to look reasonable. Please be creative with your theme, make it a little bit different. Doesn't have to be a garden with cats. It could be Superman flying around, it could be Formula One, could be anything. And of course, please don't forget to save and make sure that you bookmark your final project.